Well, good afternoon. This is David Eastwood, Geotech Engineering and Testing. Welcome to our webinar on environmental and geotechnical engineering consideration for design and construction of site development facilities, really in Texas. We got a lot of engineers here, a lot of land development engineers, a lot of site development engineers, um, builders and contractors, civil firms, general civil engineers. Got about 130 people, RSVP. This is my contact information, David Eastwood. Email de@geotecheng.com. 713-699-4000. You need to reach me. This is going to be posted on YouTube, so you can go watch it anytime you want. There's like 35 other programs out there on YouTube that you can go watch. And after you watch it, you can send me an email, then we'll send you your PDH. If you have questions throughout the program, go ahead and shoot that question. You can put it in chat or Q&A. And I kind of check every once in a while to see if I can read it, So, I'm going to ask the questions as we go through this. Geotech Engineering and Testing has been in business for about 40 years. We have about 60, 65 people, engineers, geologists, technicians, drillers. We work all over Texas, Louisiana, New Mexico, Oklahoma, New Mexico. We have our own rigs. We can get out on projects quickly. Projects, site development projects. We can have a bunch of buildings. Some of these site development projects could be McDonald's out there, Jack in the Box, all these guys getting out there at Chick-fil-A. They got to go out there and get their sites and develop. And, Walmart, man, I used to do tons of Walmarts back in the old days. I haven't done them lately, but Walmart's a great client. They're not developing as much. Academy, they're still active. Best Buy, Kroger, they're building their facilities every once in a while. HEB, they're growing. They're still going strong. There's a lot of service stations going around. There's still a lot of service stations. Buc-ee's, they're strong. They're not doing as much in Texas, but I guess they're growing throughout the U.S. Apartment complexes, a lot of multifamily. Banks, branch banking, it's not very active anymore. Motels, they're still building them here and there. I see them, popping everywhere. Oh, I don't know what happened here. Car dealerships, they're still going. I see them, going to all these guys that need sites, that need to be developed. And I don't know what's going on here. There's something gets messed up here. Schools, we got a lot of schools going on, and we do a lot of school projects. Parking lots, these facilities have got parking lots that could be concrete parking or asphalt parking. It's concrete stuff. There's a concrete. The Popeyes going out there with the concrete paving around it. Chick-fil-A got concrete paving. McDonald's, concrete paving. Golden Corral here, going out there with their asphalt paving. Here's the asphalt paving, Denny's. Walmart uses a lot of asphalt for their pavements. I guess it's cheaper. Here's a Walmart again with asphalt paving. Sam's Club out there, they got asphalt paving. More Walmart asphalt paving. Some of these service stations, Flying J, asphalt paving. Some of these pavement are subject to heavy truck traffic. So you're going to have to design them for heavy truck traffic. So a lot of times, a lot of these site development projects, you design them for auto or light truck, but some of these service stations where they got these 18 wheelers, you got to design them for the 18 wheeler truck traffic. That's a concrete site, that they're using heavy truck traffic. Dumpsters, these dumpster pads, they got concrete, which I recommend, of course, using concrete for dumpsters. I don't recommend asphalt. And there's a lot of load out there picking up these dumpster storage units. It's going to tear up that paving. So I highly recommend using concrete. A lot of these site development projects that have big signs that we have to worry about sometimes. These signs are subject to lateral loading, uplift loading, compressive loading, moment. Big signs. You can see them, Flying J there, Shell. Canopy on these service stations, they got these canopies. And then, of course, the wind loves to get underneath them and lift them up. Got a lot of uplift loading, lateral loading. So there are all kinds of canopy. For some of these service stations, you're going to have these storage tanks that dig a hole and fill them up with pea gravel and put their tanks in. Um, Got to compact all that. We recommend concrete paving over where the tanks go, not asphalt. Detention pond, all these facilities require detention park as a part of site development. You got to worry about detention ponds. Um, so what we're going to be talking about today is site development projects, site acquisition. You got to do a phase one environmental wetland study, faulting for the bigger sites. You got to do soil testing, lab testing. You got to worry about expansive soils, PVR, potential vertical rise, the building foundations, parking lots for concrete, and also asphalt paving, dumpster pads, stabilization, detention ponds, sign pole structures, and in service stations, we have to worry about canopy structures and underground storage tanks. So these are some of the stuff I would look at. Side conditions, I mean, they go out there and get these pads out there, uh, commercial areas, and they want to put a bank in there or they want to do some kind of a development. And see them, some of them are cleared, some of them are wet. You got water on them. Nice grassy areas, heavily wooded areas, cleared areas. You got to do a phase one environmental site assessments. Make sure you don't have any contamination before you buy that property as part of your feasibility. ASTM 1527. Some of these old service stations that are, near the project site, they have leaky storage tanks, and these tanks can be leaking. And if they do, they can contaminate your site. Those steel drums can contaminate the soils and groundwater. And if any of that contamination reaches your property, you're responsible for cleanup costs. This is Leak City. They got these tanks in here. These tanks leak. You're responsible for cleanup costs. You go along 225 out there, industrial areas. They have a lot of this industrial waste here and there, and so you guys got to watch out for that. You know, that can cause contamination. Pipelines, you know, they bust. They can cause contamination. Landfills. You got sanitary landfills. You got industrial landfills. They got the waste. When it rains, the water gets into the soil and groundwater called leachates. Can go reach to your property and can cause contamination. Cleaners, they got underground storage tanks, some of them on site, and they got carcinogens, chemicals, and these chemicals are cancer causing and can cause problems. So you got to worry about, you know, cleaners. If you're developing site development out there, inner city, like in the Heights area and Midtown, you got to do some tear downs. So as you do tear downs, you got to worry about asbestos, lead-based paint. You can't develop in the cemeteries. You got to look at aerial photos to see what the site looked like before you buy it. This is a Walmart project out there at FM 1960. Here, the site was 1989. It was all wooded area. There was nothing going on. It's like yesterday, 1989. Then they started building it in 2005. You can see all the developments. Here's a Home Depot on 59 North, Humble. 1944 was all heavy wooded. 2002, they started building it. And you can see that, you know, near the site, you got car wash, gas station, discount tire, dry cleaners, manufacturing. Um, so all these sites, you know, auto repair places can cause contamination on your project, kind of a risk-based analysis. Risk of any of these things can cause contamination on your site. This is a track out here in the Heights, North Main. 1925 with just a house there. 1969 shows the service station. They were going to go out there and build a bunch of condos here. So when we did a phase one, we identified the service stations. We recommended the phase two. When we did the phase two, we found a bunch of contaminated soils. So we have to dig out a bunch of that contaminated soils and move it away. Here are red dots or well, oil wells around the property right here. That's near Kingwood. And when there's oil wells, there's oil pits where they store, you know, some of the oil that comes out. The oil wells, you know, so that can cause contamination. If this is your site right here, we go by 1 mile around it. Look at all these red dots and can have a potential contamination on this site. There could be cleaners, service stations, Superfund sites. There could be hazardous waste sites. It could be landfills. So it's kind of a risk-based analysis. It gives you a table, gives you a leaky underground storage tanks. There's 14 of them near this site. One of them within 1/8 of a mile. The other one's within 1/8 to 1/4 of a mile. Two of them within 1/4 of a mile to half a mile. There's about 12 underground storage tanks near this site. One of them within 1/8 of a mile. 5 of them within 1/4 of a mile. And there are all the kinds of other stuff that can be present uh, near your site that can cause contamination. So when we do a phase 1 environmental site assessment, we do a site reconnaissance. We check with EPA, Texas Railroad Commission, TCEQ, look at the historical, use of land. We do interviews, check with property title reviews. If there's an old building there that was built before 1980, we'll look at asbestos and lead-based paint. We evaluate the risk of contamination, and if there's a risk, we recommend the phase 2 environmental site assessment. If you find any RECs there, a phase 1 environmental site assessments, is when you have potential for contamination. You go out and start digging, and you find a bunch of oil out there, free product, and you got soils that have got a lot of contamination. Soils that are contaminated with chemicals and hydrocarbons. You see a lot of that along 225 out there east of Houston. There's a lot of pipeline. There's potential for pipeline rupture. Damage to wildlife, wellheads, remediation. If you find a bunch of contamination anywhere on your site, then you may have to, one of the things you can do is dig it out and stockpile it, put plastic sheeting on it. So if it rains, water is not going to, get into the waste. You put it in the containers, cover them up, take them to industrial landfill, compact the hole to 100% standard Proctor density, not 95, 100%. Make sure you can put a structure on top of it. As part of site development, again, you got to check for wetlands. So you hire wetland expert to basically evaluate the bodies of water on their property. These are the areas that are inundated, saturated surface or groundwater at frequency, duration sufficient to support uh, prevalence of vegetation. Typically, in saturated soil environments, wetlands could include swamps, marshes. They're regulated by the U.S. Corps of Engineers. These are some pictures of wetlands. A lot of them in the Galveston County, and these, tall grass. Seawater was all the way up here. Again, you can see that we got wetlands in Harris County, Montgomery County, Galveston County, Brazoria County, Waller County. Some picture of I-45 South near Galveston. And here's a site out there in Leak City. There was a wetland here. We couldn't build here, so we developed a subdivision right here. But we couldn't do it here. This was a wetland. These are some of the vegetation that grow basically in a wetland environment. And you can see that these trees, the water goes all the way up. To have wetlands, you should have water, plants, certain plants that grow in a wetland environment, hydric soils, black smelly soils. And so hydric soils, water-loving vegetation, wetland hydrology, saturation for 7 days during growing season. If you have all these three, then you have potential wetland. And if there's water on the property, if you want to know, well, is this water jurisdictional water? Or you got to go out there, deal with the Corps of Engineers, and there's a form, dealing with that, and you fill the short form, and hopefully there's no wetland. If there is, then you're going to have to deal with the Corps of Engineers. It may take a long time to evaluate that. The wetlands are basically regulated by the U.S. Corps of Engineers 1987 Wetland Design Manual. On large site development projects, you may worry about subsidence and stuff. Not on the small ones. If you're doing it Donald's, you don't have to worry about it. Subsidence can be, basically cause compaction of the soil from groundwater removal. We have a lot of subsidence in the Houston area. Initially the ground looks like this. You got a flocculated clay structure. And when you take the groundwater out, the structure of the soil become what we call disperse, and it's going to settle. You increase the effective stress in the soil when you take the groundwater out, and it's tends to settle. These are aquifers in the Houston area. We got a Beaumont clay. Below that, you got the Chico aquifer all the way down to Jasper. This can go down several thousand feet deep. These are big bodies of sand. As you take the water out, the ground starts settling, all subsidence. And he goes all the way out here to all these different, counties. This is the Grimes County going out there. And that's several thousand feet. These are bodies of sand. And you drill holes in it, you pull the water out, that ground's going to subside and cause flooding. This is Baytown and Goose Creek oil field. It's, basically it's got 3 foot of water on it now. And you can see the areas that experiencing subsidence. They tend to flood. This is a wellhead at Baytown. That's where it used to be. Then the ground subsided, and you can see the void underneath it. So these are the areas that are flooding as a result of subsidence. This is Brownwood subdivision near Baytown, 1944 Exxon. I guess from what I heard, they used to buy land out there and give it to their executives to live on. 1953, 1978, starts disappearing. 1989, 2002, 2012. So the area starts subsiding, which causes flooding. So New Orleans got a major subsidence problem too. This is the Houston area subsidence, 9 feet near Ship Channel between 1906 to 1987. It's not elastic. When you stop taking water out, it's not going to come back up. So it's going to already, basically subside. This is Montgomery County. You can see here subsiding at the rate of about half an inch a year as the population grows in Montgomery County. It's going to subside because they, every time they do a subdivision, they put a well there and they pull the water out. And as they do that, the ground starts subsiding. New Jersey Village between 1992 to 2000, it subsided about two inches. The spring, the Woodlands area subsided about 1 inch between 2000 and 2021, about 2011. And of course, Katy area subsided about 1 inch between 2012 and 2020. As the population of the counties around Houston grows, and you can see places like Montgomery County grow 71% by the year 2050. And you can see Chambers County growing by 120%. Liberty County growing 93%. Waller County is going to grow 79%. And as these areas grow, there's more chance of subsidence. Just a predictive subsidence between 2010 and 2050. And you can see Harris County here and Fort Bend County here. And these values are in feet. Some areas going to, subside 2 feet. And as you go down here, you can see the Galveston County and Brazoria County, half a foot here. Montgomery County, it's going to South Montgomery County and drop about 6 inches. We're going to water authorities to reduce water removal. So that's kind of like got North Harris County Water Authority, West Houston Water Authority, San Jacinto Water Authority, North Fort Bend, and various water authorities. So As you use surface water, of course, you do subsidence. This is Addicts area dropping roughly about half an inch a year, number of years, compaction, using extensiometer device. Pasadena, kind of leveling off. From what I understand, they go into surface water system. Faulting. So if you got parts of the Houston that dropping as a result of subsidence, and there's other parts that are not subsiding, there are cracks in the ground that have been there for millions of years. These cracks become activated. They're called geologic faults. They extend about 100 miles from the coastline inland. So, they go all the way from Galveston to Huntsville. So if you got developments anywhere going out there, if you're in Houston and Huntsville, you got to worry about potential faulting. These are cracks, can be a couple 100 feet deep. There's about 300 faults in the Houston area from Corpus Christi to Beaumont, and they kind of move some of them at a rate of about half an inch a year. You see the commercial development, the fault going this way towards it. That's the lineation going out there towards this house. This is the downthrown section. It's the upthrown section. It's what we call shear zone. Again, you can see the upthrown section and downthrown section. This is the shear zone. That's the Woodlands area, Carlton Woods. There was a major litigation a few years ago out there on faulting. There's another house sitting on top of the fault. You can see the lineation from aerial photo, cracking and the paving and going that way towards that structure. There's a bump in the road. This is the post-Stoke fault out there near Galleria. See like that. Definitely drop. You got an upthrown section. You got a downthrown section of the fault. This is what we call scarp. That's the failure surface. These are the soil layers that are out of whack. Could be clay here, sand here, clay here. And of course, to find that scarp, you can do geophysical borings and run and do testing like resistivity, trying to find out the exact location of this thing, the scarp. You can look at aerial photos. That's what we do as a part of our investigation of faulting. We do what's called a phase 1 fault study. We recommend that on projects. This is the lineation on the fault. You can see the downthrown section and upthrown section is darker on the downthrown section because there's more moisture. So you can see the lineation like that. The downthrown section, upthrown section. If the side is wooded, we worry about or tall grass. We use LiDAR to see if you can see any change in elevation that uses basically laser light to measure distance. And here's the LiDAR map. It shows the faulting. That's an actual track. And they were going to build condos here, and they were starting building it. They found that there's a fault there. They never checked the faulting on it. They should have. Anytime you do any kind of a development, site development, you got to check for faulting in Houston area. Like I said, 100 miles inward. If the site is wooded, then we do hydroax it. We don't get a dozer to start taking the trees out because we don't want to change the elevations. We don't want to remove the scarp from your project. So you hydroax this stuff. Then you go out there and look at it to see if there is any change in elevation anywhere. We got faults in Dallas, San Antonio, and Austin. They're not active. The faults in the Houston area are active. So you're going to have to worry about it. You can see all the faults out there in Houston, Beaumont, Corpus Christi. Here's a map that shows some of the faults. We have a lot of maps that shows faults, but They don't show all the faults because a lot of the private developers do not want the faults shown on any kind of a public map. So we have it in our library, but these fault maps are not accurate. They don't show all the faults. You can see the faults, got a lot of them near Pearland. And you can see the faults here in the Houston area. That's the ticker, the down-thrown section, up-thrown section. All the faults. Here's a track out here in Pearland. They got to develop it. But see near the salt dome, Makova salt dome, and you can see all the faults near the area. Here's the actual fault going through the property. That's the property, and here's a pipeline. They develop one and know what to do about these faults. Well, we developed what's called a hazard zone. It's about 130 foot wide. In the down-thrown section, it moves twice as much as the up-thrown section. Well, it moves more. So the down-thrown section space is bigger, twice as much as the up-thrown section. So if this is 130 foot, the down-thrown section is about 80 foot. The up-thrown section, is about, 40 foot. So you can turn that into a linear detention or to a park, but you cannot build houses on it or commercial structures, multifamily and stuff. This is a school out there on Pearland Parkway, right there. It's a near a fault. It's sitting on D piers with anchor bolts. That's the beam. To adjust the elevations of it every once in a while, if it moves, make sure it stays level. So if you got a project where you need site development as part of your feasibility, you got to do borings out there. We go check the soils. We got our own rigs. We got like 8 rigs. And of course, you can see this just goes 120 feet. This goes 120 feet. This goes portable, 20 feet deep. These are truck mounted rigs. They go about 30 feet deep. Here's a drill rig out there doing the borings. It's a McDonald project. They're going to tear it down. They do it at nighttime. AutoZone, Kroger, Jack in the Box, a motel, Buc-ee's. We do borings inside the buildings that have got foundation problems using our portable rig. When we do forensics, if the site is heavily, it's wet, stuff like that, can't get to it, we use our buggy rigs. It's a buggy rigs, cost more money. On small projects, we can pull on an ATV. Behind the ATV here, our portable rig goes about 20 feet deep. If your site is wooded, we have to do a clearing, create a path for the rig to get around. Most of our sampling is done with a Shelby tube sampler. This is a 3-inch diameter tube. You push it hydraulically into the soil. You get a soil sample. That's what it looks like when it comes out. Clay soil. Cut the ends. You put it in foil. Put it in plastic bags. Put it in a wax box. Take it to the lab. Look for root fibers. We use root fiber for the design of our foundations. Root fibers from trees. Extend to an area where there is no oxygen and no water, and so they die there. That defines your active zone depth. That's the depth at which soil experiences shrink swell. See it like that? That's the root fiber. As you go deeper, your root fiber becomes smaller. Standard penetration test. That's a 140-pound hammer. Drop 30 inches. We cannot get tube samples in sandy soils, so we do a standard penetration test in sand and silt. It gives us the density of the soil. It's 140 pound, drop 30 inches. We drive into the soil 18 inches. That's 6 inches, 6 inches, 6 inch. That's a standard penetration test. Split spoon sampler. If your blow count's within 0 and 4, you got very loose material. Within 4, 5, and 10 is loose. Medium dense between 11 and 30. Dense 31 to 50. Very dense above 50. Most of our projects, you got very loose sands. And so we support our light structures. Like if you got a McDonald out there, you can put it on a slab on grade. You know, we designed it for very loose sand. If your soils are sandy. If you Dallas, San Antonio, and Austin, you're going to get rock. You go deep rock, you're going to hit like limestone, shale. You core it, put it in a box. You do testing on it. Number of borings. If you got a small site, so you got a McDonald's, a Chick-fil-A, or Jack in the Box, you do a couple of borings in the building to 25 feet. Walmart's, you know, they got specs. You do one boring every 10,000 square feet to a depth of 25 feet. Hotels and stuff, depending how big they are, you do one boring every 3,000 square feet to a depth of 25 feet, or like a 2-story, 3-story hotel. Apartments, you know, typically they go on post-tension slabs. Sometimes they go on piers, but not very often. You do borings at least 20, 25 foot, you know, deep. You do one boring per building. Parking lots, you know, we do typically, you know, for small sites like Chick-fil-A, we do 3 borings to a depth of 10 feet. Walmart's and Home Depot and Costco, Sam's Club, Target, you do one boring every 10,000 square feet. Hotels and stuff, you know, depending how big they are, if they're small, one every 3,000 square feet to a depth of 10 feet. For sign structures, we do at least one boring to a depth of 30 feet for canopy structures. For service stations, we do a couple of borings, 25 feet. Storage tanks, at least one boring to a depth of 20 feet. Detention pond, you got a small site like a dollar store, O'Reilly, or AutoZone, or McDonald's. You do one boring to a depth of 20 feet. You know, you get a big project like Walmart, you do 3, 4 borings to a depth of 20 feet, 25 feet deep. Groundwater, of course, we measure the water level when we do the borings. It's not very accurate. The water table fluctuates throughout the, you know, seasons. So don't count on the water levels. You may not see any water. That means that doesn't mean there's no water there. So because our holes are so small, it takes a long time for water to come in to percolate into the hole. So the water levels are not very accurate. The way you measure water level is you get a tape measure with a weight at the end of it. You throw it in the hole. When it goes hit the water, it goes plumb. Sometimes we run into perch water table. If you're out there developing a site, let's say a Walmart out there in Katy, you got these sandy soils over clay, and these sands just hold the water. It's like a bathtub over impermeable clay. Water just sits there on top of the clay. It's called perch water table. Here's a site that they have perch water table. You can see it's pumping. So a client calls me and say, "Hey, what do I do here? I've got a site that's pumping. It's really bad. You know, how am I going to build anything here?" So to improve sites that are pumping, You can open it up, let it dry, and improve the drainage. You can do soil mixing. You can do chemical modification. You can do removal and replacement of the sandy soils. To opening it up, basically, you open up the soil, let it dry, but that takes a long time. And of course, we could always get rain here in the Houston area, so it may not be a good option. If you're out there in Dallas, Fort Worth, and you don't get rain for a month, that's fine. Drainage on big sites, you do bleeder ditches. You drain the sandy soils. You dig a hole, basically a trench, about 2, 3 foot wide, 3 foot deep. It drains the sandy soils. You put them on a grid. Take it to a detention pond, a low area, and then pump it off-site. If you got sandy soils, you can mix the sands that's on site with clays. Let's say you got a detention pond, you run into all this clay in your detention pond. You take that clay, you load it up on a truck from the detention pond, or if you may have a channel, and take it to the site and dump it on top of the sand and disc it in. You chop it in there, mix it, compact it. So if you have a bunch of clay and it's 60-40, 60% clay, 40% sand, you will reduce the chance of pumping. If you're in a rush, you can do chemical stabilization. You can use fly ash, you can lime, you can use cement. This is hydrated lime if you can get it. It's powdery. You put it on the soil, mix it in, and it soaks up the moisture. Quick lime is even better. You put it on the site and actually mix it in. Do not use lime slurry. It's got too much moisture in it. You can use fly ash. It's dry fly ash. You can remove and replace. You can remove the sandy soils and then bring in structural fill, clay type material, and compact it with sheep's foot. Lab testing. These are some lab testing we do in the lab. Liquid limit test. In this test, we add a bunch of water to the soil in the cup. And when it becomes liquid, we take some of that sample, we put it in here in this cup, cut a groove through it with this spatula, turn the handle 20, 30 times. When the groove comes together, you get a sample of that soil, you get the wet weight of it. And so we can find out how wet it is, how much soil weighs when you got this in the liquid format. You put it in the oven and dry it up. And so you get a dry weight of it and subtract from the wet weight, and you find out how much water is in the soil for it to behave liquid. It's called liquid limit, how much water. Then we do plastic limit test. In this test, we roll the sample to 1/8 of an inch and get the wet weight of it. And you put it in the oven and dry it up and get the dry weight of it. You want to know how much water is in the soil for it to behave semi-plastic. When we subtract liquid limits from plastic limit, you get plasticity index. So if your liquid limit is 70, your plastic limit is 30, your PI is 50. So if your PI is less than 20, you've got low soil potential. In 20 and 30, it's got moderately expansive soils. Between 30 and 40, got highly expansive soils. Above 40 is very high. We'll also do a string test. See how strong that soil is to get you lateral bearing capacity for your projects. It's a hand penetrometer test and a 12 vein test. In a hand penetrometer test, you push that hand penetrometer, push it into soil. You can read here what kind of a strength it has. 12 vein, you put it at the end of the sample, measure the torsion, and estimate the soil strength. In unconfined compression test, you take that sample, that's a proving ring, that's the deflection. You squish it and see how much load it can carry. Use that for bearing capacity calculations, trench safety. your slope stability for your detention pond, all the strength values, you need all that. Swell test, if you got a foundation system, and if you got money on the project, you run swell tests. It's not very often because it costs money. You take the soil sample, you put a load on it equal to its geostatic stress. Let's say the sample is about 5 foot deep. You put about 600 psf loading on it. You add water to it, let it swell, see what kind of a percentage swell you're going to have. Then you load it up to get the initial uh, void ratio. This is called swell pressure. And so you run a swell test like that. Way you run a swell test, you got to, device like this in a ring. You put your sample out there in the ring. Then you put it in this housing. You put the whole thing out there in a swell test machine. You add load to it equal to its geostatic stress and add water and see how much it's going to swell. And you say, okay, time for soil, 2 to 4 feet here. The soil is, the density is 126 PCF, it's got 300 PSF loading on it, and it swelled 1.2% when you added water to it. Okay. Soil types, clays. We got a bunch of clays in Houston and in Texas. Got a clay site right there. Sandy soils. We got a lot of sandy soils in Texas too. You go out there, Katy out there, south of Condro out there in 249, 290 area. We got real sandy soils out there. Go to Spandora, got sandy soils. This is the sandy sites. This is silt. We got a lot of silty sites in Houston too. Silt grain size is bigger than clay, smaller than sand. It's hard to build on. The silty site there. So we got clay. Go deeper, you get red clay. Deeper, you got white clay. Then you start getting into weathered rock. The rock in Houston is about 2,500 feet deep, so you don't have to worry about it. But if you go out there on uh, Conroe, on the west side of Conroe and 105, you start going that direction, you're going to hit some sandstone. You go to Onalaska near Lake Livingston, you're going to hit sandstone. You go to Huntsville, you're going to hit some limestone, sandstone. We do have some rock. That's a good material to build on. Fill. On a lot of our projects, when we do site development, you got to do mass grading. And you're going to build, of course, your structure on fill. It's called structural fill. So you can build on top of a fill as long as the soil is properly compacted. Minimum 95% standard Proctor density. And at every lift, we need density tests for every lift. It should be free of organics, no roots and stuff in it. These are shrinkage cracks in expansive soils. During the summertime, no rain. With time, these cracks get filled up with debris. They fill up the holes. Then we get a rain. The soil swells up. It doesn't have any place to go. It cracks at 45-degree angle. They call them slicking sides. So let's say you're doing a multifamily apartment complex and you got a pool. You start excavating for the pool. The whole side of the pool is going to collapse. That's because of presence of slicking sides in the clay soils. It's nice and hard soil, but it's going to collapse because you got slicking sides in it. Engineering analysis. We got a bunch of clays all the way throughout Texas, all the red areas. You got clay in Texas and Louisiana. The soils in Texas are variable, so every time we do any site development project, you got to know what kind of soils you have, and you need a soil test. These are the soils that can expand up to 1,500% from U.S. Corps of Engineers. So we have a lot of expansive soils in the U.S. Again, the expansive soils in Texas and Louisiana. The expansive soils. So when they did Texas land plan, they put Houston, Dallas, San Antonio, Austin, where we have a lot of expansive soils. Lubbock and El Paso, they got caliche and sandy soils, so they don't have to worry about heave. North of Buffalo Bayou in Houston is sandy soils. South of Buffalo Bayou, you got Gumbo Clay Beaumont Formation. North of it, it's got Lisi Formation, which is sandy. So if you start going around Houston from where I live, which is near Splendora, you got real sandy, silty soils here. You start going to Kingwood, you got fat clays near the 59. You go away near the Lake Houston, you got sandy soils. Dayton, Liberty out there. Dayton, you go to Bellevue, Baytown, LaPorte, Pasadena, Galena Park, Channelview, Seabrook, Lake City, Dickinson, Friendswood, Pearland, Missouri City, Sugarland, New Territory, Pecan Grove, Rosenberg, in Richmond, East Bernard, Manville, all you got really highly expansive soils. You start coming out to Cinco Ranch, their soils become sandy. That's where your soil starts pumping because of the perch water problem. Brookshire, Katy, Sealy, you got real these nasty, silty, sandy soils. Bridgeland, you got sandy soils. You got some clay in there too. Farfield, you got a lot of sandy soils with some clay. You start going to Tomball. You got some areas real sandy, some areas real clayey. You start going to Woodlands. You got sandy soils in some areas, most of it. South of Conroe is real sandy. North of Conroe near Willis is real fat clay in some areas. You go inner city, Westview, Bel Air, Tanglewood. You got highly expensive soils. You got oak trees and a bunch of attorneys. So watch out. It's a typical boring log for fat clay, gumbo clay. Got a shear strength of over 1,000 PSF. Goes all the way down to 25 foot. Got a PI of 59 and 48. Highly expansive soils. No water. Here's the sandy site. Got sand all the way down to 25 feet. And the water is about 30, about 8 feet. And it's a medium dense sand. So you put a building here, you put it on a spread footing. So we plot the borings along your project site. You got from 0 to 12 feet. You got clay. Below that, you got sand. Below that, you got clay. So depending on the type of the soils, we come up with recommendations for foundations and, of course, paving. So if you got foundation in here, if you got expansive soils, your foundation may have to go below the sand layer. So you may have to use what's called slurry with the construction for your pier construction. So potential vertical rise. It's basically PVR is expressed in terms of inches of potential swell at each site. So as part of a feasibility for every site, we tell you what the PVR for that site is. You can build stuff out there with up to PVR of 4.5 for floating slab systems, like post-tension slabs. For pier foundations, your PVR should be limited to 1 inch. Here's a PVR map of Houston. You go out there near where I live out there, New Caney, Porter. You got about PVR about 1 inch out there in Splendora. You start going out there to coming down to Tascasita, you got a PVR of about 3 inches. You go Humble, about PVR of 1 to 2 inches. And then you start going out there east, you got out there Mobeview, Cosby, and all that. You're going to have 5-6 inch PVRs. You go out there in Texas City, you got to have 6 to 8 inches of PVRs. Baytown, about 5 inches. You go out there, places such as, Brazoria County, Going to have 5 inches of PVR. Rosenberg, some parts of Friendswood, all those areas. You got 5, 6 inches of PVR. Richmond, about 5 inches. Fulshere's got a crazy soils out there. Some areas are sandy, some areas are fat clay. So you can have PVRs 1 to 4 inches out there in Fulshire. Near Brookshire and stuff about 1 to 1.5 inches. 290 corridor out there, about 1.5 inches, 1 inch. Same with 249, real sandy soils in this whole area. And potential for perch water problem. PVR for buildings, of course, should be limited to 1 inch for structures supported on pier foundations. PVR for a post-tension slab or a conventional reinforced slab can be as high as 4.5 inches. That allows the slab to move. It floats. Some of the things you can do to reduce movement is putting sprinkler system on your site development projects all around. So if you have a post-tension slab on your apartment complex, so you put sprinklers all around it so that keep the moisture uniform. You're going to have movements if you have differential moisture. So if parts of the foundation is dry, another part is wet, the wet area is going to swell. If you have expansive soils, the areas that are dry, they're not going to swell. So you're going to develop differential swell that causes movements. You can extend your grade beam in the exterior beam deep. The deeper your exterior grade beam, the less moisture is going to get underneath your slab, less movement you're going to have. One way to reduce the movement. If you're going to have planter areas, put them all around the building to allow water gets everywhere to have a uniform moisture. Or you can put concrete all around the whole structure to minimize any change in moisture and keep it uniform and don't let it to fluctuate. If you put non-uniform situation where you got a bank structure in here, you got paving in here, you got grass in here, this area is going to heave up and down, you're going to get cracks right there. Same way here, you're going to have movements here, no movement here where you got concrete, you're going to get cracks right here. Some buildings, they got these little skirts that helps out. Keep the moisture under the slab uniform. You want to have positive drainage away from your slab in the grass. You want to have 5% slope. In your pad, when you build a pad, don't use sand for your pad. Use select structural fill. Or use the structural fill if you have a floating slab system. So if you got a post tension or conventional reinforced slab, you can use fat clay underneath your foundation as long as your PVR is less than 4.5. If you have pier foundation, you cannot have PVR more than 1 inch, so you have to use select structural fill. So if you got a site with a PI of 60 and the active zone of 10 feet or movement active zone of 10 feet, your PVR of about 4 inches can be reduced to about 1 inch by removing 7 foot of soil, replacing it with select fill, which is not economical. Nobody does that. This is a select fill. The select fill is a soil with liquid limit less than 40 PI between 12 and 20. In minimum 50% past number 200 sieve. Structures for some of these projects, it could have a wood frame. If you've got a small project, you can have wood frame structures. Of course, a lot of these apartment complexes, multifamily, they got wood frame. You can have prefabricated stuff like Taco Bell and stuff, or you can have CMU tilt wall for like Kroger's and HEB stores. Wood frame, if you got a small structure, a typical drive-through site development project, they go wood frame on those things. Concrete masonry unit, this a lot of these Kroger's, they go with CMU walls. Tilt walls, some of these buildings, like Target use tilt wall. You know, Walmart likes to use block wall system. So these are tilt wall for Target. Prefabricate, you know, some of these buildings are, you know, come in pieces. You just slap them together real quick. Top, you know, structures. So the type of foundations we use for these buildings are, you know, it could be deep foundations such as drill piers, piling, auger cast piles, silica piles. Could be a conventional reinforced slab, post tension slab, spread footings, foundation and risks. You know, I mean, you got a building like a Target, you can't have any movement on this big building. So, you know, if you're in Dallas, Fort Worth, and Frisco, you got a high PVR soils, you may want to go with structural slab with piers. If you're in Houston, you go in there with, you know, a few feet of select structural fill with deep piers and put the tilt wall building on it. That's a slab on fill supported on piers. Um, if you got a project, you got a Taco Bell, you got to go in there, quickly put it in there. It's raining, you can go with a super slab. That's a 6-inch concrete slab with beams. There's no compaction required underneath it. It's called super slab. Or you can go if you have, you know, nice weather, you got a Chick-fil-A, you go out there and put it on a slab on grade foundation system or a post tension slab. Drill piers, if you got a big project like HEB and stuff, or a Home Depot, you got a drill pier, you got an auger rig, you got a reamer rig, you drill the hole with the auger rig, and then you go ream it. You measure the bell. That's your shaft out here. Make sure you have no more than 3 inches of water in there. You put your cage in, pour the concrete, make sure it doesn't hit the sides. That's your bell. This is your shaft. You bring the steel in. You don't tie it in. You just let it sleeve it in here. That's the sleeve on the drill piers. That's your beam. Here, steel coming in here. You put void boxes if you have expansive soils between the piers. It's a typical tit wall building here. You can see the makeup here. You got all the piers in here. That could be for like a Target store. These are piers. You put isolations between the columns, isolation joints, and then the slab. You put enough select fill or you do chemical injection underneath the floor slab to get the PVR to less than 1 inch here. You can see that again. That's a Target store. Got interior columns. They're totally isolated from the slab here. Now, if you got a tilt wall over there, they got steel that comes out from the slab that's connected to the tilt wall panel. So actually from a tilt wall panel to the slab. The way you determine your pier depths is very important. We see a lot of these buildings, they got foundation problems. So if you use a pier foundation, you have to know about some concept. That's a zero movement line. That's the soils above this. Below this area does not heave. The soil above it will heave. That zero movement line is equal to movement active zone. Then there's active zone depth. So active zone depth in Houston could be 25 foot deep. Okay, but the movement active zone is only 10 foot deep. And you want to anchor the pier, anchor it below the zero movement line or below the movement active zone to resist uplift. This is actually scientific. They just don't slap the piers at 10 foot or 12 foot here. We actually look at the moisture active zone. When you have a tree, of course, your active zone is deeper. We determine the depth of active zone by when you hit a sand layer, when you hit a rock layer, 2 foot below the lowest root fiber, when the changing suction is less than 0.027, when your liquidity index in soils becomes vertical, depth of slicking sides in or historical water table. But your movement active zone is usually equal to the active zone is lower or lower. Again, In the Houston area, it doesn't exceed 10 feet. Dallas, San Antonio, and Austin ranges from 12 to 15 feet. This is with the pier end, you gotta have to resist the downward movement, compressive loading. You got end bearing and the skin friction. You don't count on skin friction within the active zone because this shit shrinks. And then, of course, you resist the uplift by anchoring the pier deep enough above the the zero movement line or movement active zone. The soil grabs the pier, wants to lift it. Below that, you want to anchor it to resist the uplift. And you don't count on the bell to resist uplift because by the time the bell resists uplift, you're going to have 2-3 inches of movement. That's not acceptable to really. So don't count on the bell. These are some sound walls out there near Pearland. You go out there and look at them, see some of the piers sticking out. So if you got a Chick-fil-A, you want to put it on piers, they got a highly expansive soil, you got a PI of 60, you got a movement active zone of 10 feet, your pier is going to be about 20 foot deep. It's twice the depth of the active zone. There's a Lowe's project. You got a PI of 50, your active zone depth, movement active zone of 10 feet. You got to put this on piers. You're going to use the slurry method of construction. You put the pier in the sand, not above the sand. You got to be about 20 foot deep, 25 foot deep, because the skin friction in the sand is lower. So that's how you determine pier depths. So the deep foundation depth on expansive soils in Houston area, if your movement active zone is about 6 to 10 feet, your piers are 12 to 20 feet deep. In Dallas, if your movement active zone is 15 feet, your piers are 20, 30 feet deep. San Antonio, about 15 feet. Same with Austin. All these pier depths are 20, 30 feet deep. Okay. So depth of, of course, movement active zone in Houston is 10 feet. In Dallas, San Antonio, and Austin is 12 to 15 feet. So if you got a Kroger that's going in or a Target, you got the foundation system here. You got your columns over here. You put it on deep piers here. You put the slab on grade here. And you calculate the PVR should not exceed 1 inch. These are your columns coming out. You put isolation joints between the column and the slab. Allow the slab to move up and down if you needed to. These are isolation joints. The isolation joints. The column coming in. You saw cut around your column. Your column is not going to move usually. Your slab potentially can move. If you don't have some kind of a joint between your column and your slab, you're going to get cracking. So you can put a square or diamond shape or otherwise you're going to get cracks. I see people go out there and saw cut afterwards. It looks pretty bad. So you just put them in at the beginning. These guys went out there and saw cut it later. Here's a Walmart that they saw cut only half of it. So it's not good. In the floor slab areas, if your soils are expansive, you go with a structural slab system or a slab on a structural fill, lime stabilization of the on-site soils. Your green option, you can stabilize the on-site expansive soils. Put that under the slab or do chemical injection. And of course, if your soils are non-expansive, you compact the soil and you put your slab directly on top of it. That's again, we talk about structural fill, soil with liquid limit less than 40, PI between 12 and 20. Here's a green option. If you got site that's highly expansive, you lime it and you lime stabilize. Let's say you need, PVR of 3 inches, 4 inches. You may have to go out there and lime stabilize top 6 feet or 5 feet and put it underneath the slab to get the PVR less than 1 inch. A lot of times you do combination. You may want to do chemical injection to a depth of 10 feet and then lime stabilization to 3 feet below. That way it costs you save some money here. Structural slab on commercial, you have Texas A&M, projects. They use a structural slab. Rice University, University of Houston, a lot of the major structures, everything going on a structural slab system because they got expansive soils. Just isolate the slab from expansive soils. These are structural slab systems. All these pipes over here, they got to be isolated from the soil. Otherwise, they can push your plumbing up. Isolate the plumbing from the expansive soils. These are the pipes underneath your slab. If they're within expansive soils, they can actually push against your tubs, your sinks. Move this stuff. I had a project near Dallas where some of the stuff are moving because the plumbing was pushing stuff up. They were expansive soils. Here's a structural slab on voids. If you got a site and you got a highly expansive soils, you can use void boxes. These are cardboard void boxes that you can use. And the thickness of it is determined by twice the PVR. If PVR is 4 inches, your void boxes is 8 inches. You put the void boxes in the grade beams as well as in the floor slab areas. There's some void boxes, courtesy of City of Deer Park, one of their buildings. Thanks for providing the slides. You put a storm cover over the void boxes so that the steel does not puncture holes in the void boxes. So you put the void boxes in, you put the storm cover on top of it. You put the steel on top of that. Put the vapor barrier in. Put in the steel or concrete. Concrete should have a slump of less than 5 inches. Pump it in. These are your beams. More concrete. More void boxes. They got void boxes in the beams. That's your piers. Piers, void boxes. Isolate the plumbing from the expansive soils. Helical piles. You can support some of these buildings on helical pile systems. This is an auger. You drill it into the soil. It doesn't matter if you got water or sand or clay. It's a very good system. It lasts about 75 years. You put them in, you just screw it in, and it can support your foundation system. This is a light structure out here. They got to put them on a helical system. You just screw them into the ground. That's just like a pier. It's a bigger project. They can go to like 1,000 kips loading. You get beams and you screw them in there and you put your steel in there. If you need lateral loading, you may want to drill a large diameter hole first. Put in your helical, fill it up with concrete to resist lateral loading, or you can put them in a batter, resist lateral loading. Again, you put them in beams, 6 to 8 foot spacing. Put in your void boxes, put in your steel, pour concrete. Auger cast piles. If you got a heavy structure, for example, you put in one tilt wall, you got sandy soils and shallow water tables, stuff like that. You may want to go with auger cast in place piles. You got a heavy loads with tilt wall type stuff. You just drill a hole out there with auger cast piles. And it's in like an auger, it's got a hole in the middle of it. Like that. This is your cage. After you drill it in, put in your grout, you push your cage in. Conventional reinforced slab, if you got a lightly loaded structure like a Taco Bell stuff, You go in there and dig your beams. Just depending what you got. That's a conventional reinforced slab type foundation. You go your interior beams, your exterior beams. Those are your beams like that. You got to put steel in it. You got a 4-inch slab. You do your waffle slab. That's the kind of retire. That's the multifamily here. Yeah, the plumber goes out there and tears up everything. You got to go back with the jumping jack and compact everything. Make sure it's nice and clean. You put your vapor barrier in. You use a special tape. If you got a cut in your vapor barrier, do not use duct tape. Put your chairs. Start pumping the concrete. Do not use wire mesh in your slabs. It ends up at the bottom. No wire mesh. You don't pull up on the steel like that. You don't want to steel all the way to the bottom. Total bad construction. You go out there and take a picture of your bottom of your slab, and you can see the steel there. There's a construction defect. Pump the concrete. These idiots are pouring the concrete on top of vapor barrier. The steel is underneath it. Doesn't know what he's doing. Spread footings. If you got the soils are sandy, you got a building like that. It could be a tilt wall building or, hotel. You go out and put the spread footings in. You dig a hole 3-4 foot deep, and you put a square footing. Just dig a hole, put your steel in, fill up with the concrete, and you can support your structure. Called spread footings. For apartments, for a lot of the apartments, we go with the post-tension slabs. You got a slab, you got interior beams, exterior beam. You got cables going through them at about 3 to 5 foot spacing. You got single cable going on in the grade beam, or sometimes double cables. The waffle slab. You put your cables in, you put them on chairs. It's a multifamily. Is where your sink's going to go. Got a live end when you pull the cables. Dead end. The dead end. The live ends here. It is the dead ends here. So we got a dead end here, live ends here. They're stressing it from here. The typical we use it for multifamily or residential. They're sitting on cables. Your vapor barrier should go all the way in. Could be good contact hanging out like this. Not acceptable. You got to bring it in and make sure it's in good contact with soil. For the concrete, your slump should not exceed 5 inches. Start taking the forms off. Remove the forms within 24 hours. You start stressing it, cables. Initially to 33 kips with compression in the slab. It reduces the cracking, carrying the moment and shear. You stress the concrete at these concretes at 2,000 psi. Elongation in excess of 10% should be reported to the structural engineer. Tendons, like a multifamily of a big apartment complex, got to be stressed from both ends, 100-foot spacing. You basically paint the cable before you pull it. After you pull it, you can see how far it extended. You measure that elongation. You check that with your chart. It should match. And you can see that cable stressing. Your jack got to be calibrated. Make sure you got a proper calibrated jack. Initially, we have 0 load on the cables. Then when we go stress it at the beginning, it's got 33 kips. Then it drops to about 28.9 kips after wedge seating. Then the final is 26.5 kips in tension and puts the concrete in compression. cut the ends, grout the pocket holes prior to installing the grout. Pocket holes should be clean of, grit, oil, and stuff like that. Bonding agent may have to be used. All this area got to be cleaned. Vestry pocket should be, backfilled with non-shrink grout. Do not use any kind of a grout that's got chloride and chemicals in it. That's not good for steel. Cover it up. On big projects, if you got big slabs, let's say you're doing a Walmart slab, you go out there and trowel it like this. Make sure it's nice and level. Chemical injection, if you got highly expansive soils, you to reduce your PVR to less than 4.5 inches for a small project. Or if you got a big project on piers, you got to have your PVR less than 1 inch. When you have piers, for a floating slab, should be 4.5 inches. Conduct chemical injection to minimize heave. You do what's called cation exchange. You got clay layers, they got negative charge. You add water to it, it absorbs water and expands. So what you do is reduce the negative charge by cation exchange, removing sodium and potassium, put calcium in, and it doesn't heave as much. So that's called cation exchange. Remove monovalent cations like it's sodium and potassium, replace them with divalent cations like calcium. It's a tank like this. The chemicals that are in it, you inject it into the soil. This is Sienna Plantation in Houston. You inject it into the soil all the way down. This is an actually apartment complex project out there on Brace Bayou. Brace Height. You inject it. Soil types where chemical injections are effective. By the way, you inject it all the way to a depth of 10 feet at about 24-inch spacing. Soils that have a lot of secondary structures like cracks in them, the chemicals can travel easily through them. This is A-leaf soils, got a lot of cracks in it. It's summertime, that's 2023. You can see the cracks. Parking and drive facilities. A lot of our site development projects, we've got parking lots. And some of these parking lots can be concrete or asphalt. So concrete, asphalt parking lots. 18-wheeler parking lots. Concrete 18-wheelers. We do the pavement design based on AASHTO, ACI, or Asphalt Institute. A typical concrete paving for parking areas is about 5-6 inches. For truck parking areas, about 8 inches, 7 inches. Driveways, 6-7 inches. Typical parking lots are put on stabilized soils, usually 6 to 8 inches of stabilized subgrade with lime or lime fly ash. If your soils are gumbo clay, use lime. If they're sandy, they use lime fly ash. For asphalt parking, for parking areas, 2 inches of asphalt, 6 inches of base, 6 inches of stabilized subgrade. Driveways, truck areas, 3 inches of asphalt, 8 inches of base, 8 inches of stabilized subgrade. Again, you want to stabilize that subgrade with lime or lime fly ash, depending on the soil type. Dumpster areas, they got heavy loads on them. We don't recommend asphalt. Use concrete, usually about 7-inch concrete paving. 8 inches of stabilized subgrade. Concrete jointing. If this is your building, you put isolation joints between your building and your parking lot. These are your control joints. And then you got construction joints too, of course. Control joints, you usually about 12 and a half, 13 feet apart, depending on the pavement thickness. For a 5-inch pavements, You want to put them in, about, 13, about 15 foot apart. So just depending, how far apart are you? What's the thickness of your pavements? These are control joints. Tells the concrete where to crack. You saw cut about 1/4 of the pavement thickness. Control joints are intended to predetermine the location of the cracks caused by restrained shrinkages of concrete by stresses induced by wrapping or curling. So if your pavement's about 5 inches, you like to ideally to put them about 10 foot apart. If it's about 6 inches, you want to put it at least, 12 and a half, 13 foot apart. If they're greater than 6 inches, 15 foot apart. Don't go in there with control joints at 20 feet or 25 feet. We don't recommend it. Expansion joints. ACI does not really specify expansion joints. They're a maintenance hazard. Typically, we recommend an 80-foot spacing for your expansion joints. Here you can see the projects. You can see the expansion joints. You got to go in there and fill them up. If you see any kind of a void in there, don't let water get in there. It will destroy your paving. So you got to have to put joint fillers in it, and to put them at 80-foot spacing. For asphalt paving, typically we go with 3 inches asphalt, 8 inches of space, and 8 inches of stabilized subgrade for the dumpsters. And you can see all these cracks out there next to the dumpster. The truck going out, they're trying to pick it up. A lot of distress. Signs, these signs, subject to lateral loading, uplift. These are the columns coming in. They are anchor bolts, drill piers here underneath them. This has got lateral loads, mending, compression, uplift loading on them. You got to design for those things to come up with the pier depth underneath it. So we give you lateral capacity on the piers, PY curves, L-pile, soil design parameters, how much movement you're going to expect, PY curves, the lateral loading, upward and downward, we've got TZ curves, and of course torsion, we've got T theta or M theta curves. These are L-pile soil design parameters, soil type. This is a clay 0 to 2 modulus, soil modulus of about 80 PCI, E50, that's strain at 50% of the strength, 0.01, effective unit weight of 60 PCF, soil strength of 600 PSF. So you model that and you put it into your L-pile, calculate the lateral capacity of your sign foundation. Canopy structures are the same, these canopy structures are subject to uplift, lateral load, and bending moment. Of course, compressive capacity. So you got uplift, compression, uplift, lateral load. Storage tanks, they go out there and excavate the tank. Minimal excavation for your tank. Structure for your service stations. Got to be about 1.5 to 1. Got to follow OSHA soil classification system. You go in there and put pea gravel in there. Set your stuff for your tanks. Put your tanks in. Compact the pea gravel. Start backfilling everything. We recommend concrete paving over it, not asphalt. That way you're gonna have settlement or distress. Detention ponds, a lot of these projects got detention ponds. We recommend 3 to 1 slopes on your clay soils, on your detention ponds. We can do slope stability on them to give you a more accurate ones. If your soils are sandy, we recommend 4 to 1 slopes or 5 to 1 slopes. Clay soils 3 to 1. Sandy soils, 4-to-1. Slope stability analysis. Erosion protection, typically we use grass. We recommend the buildings to be at least 30 feet away from high bank of your detention pond. We run, slope stability for your detention pond, short term, long term, and rapid drawdown. These are conditions of the undrained conditions. Long term, poor pressure, seepage, rapid drawdown, poor pressure, no time for drainage. Computer modeling. That's short term. You get a factor of safety. Long term, you get a factor of safety. Rapid drawdown. Water goes up, then goes down. It saturates your slope. And we run it to make sure you got a proper slope ratio. Factors of safety, short term is 1.3, long term 1.5, rapid drawdown 1.25. Block walls, a lot of these site projects, because we have site issues in terms of land. So we're going out there with some kind of a detention pond and maybe using block wall systems. And you got to be careful when you design these block walls. They got to have the proper design. You need to have drainage out there in the back of it. These are your fabrics that you put in there. You have to put granule material behind it, not fat clay. Okay, and leveling pad in here. You got to check for global stability and do a lot of inspection during the construction. Make sure you get the proper backfill, proper compaction, proper drainage, and make sure your design is properly done with somebody that knows how to design block walls. You got to do proper geotechnical work for any kind of a block wall system that you're going to have. Erosion protection, we use grass on projects. For your detention ponds. If you have a lot of erosion, stuff like that, you got sandy soils, use matting. These are the fabrics you put in there, you nail them in. With detention pond, allows the grass to grow through it. So in general, it's very important to do a proper geotechnical on your projects. This is the original contract, that's a change order. If you don't do it right, you're going to have foundation problem. I've worked on a lot of these site development projects, the apartments and chain stores and stuff like that with foundation problems. It costs a lot of money. If you got good pictures of the project, send them to me. I use them for presentation. This presentation is going to be on YouTube. Oh, we got a program evaluation, so just try to see what do y'all think of it. You got any suggestions and stuff like that? We're going to do a poll. See what you say. What do you think? If you need to reach me, my email is de@geotecheng.com. My number is 713-699-4000. We're going to have a bunch of seminars coming up, and so you're going to get notices about them. You're going to get a PDH on this thing about an hour and a half. Questions? I know I kind of went through it quickly, but it's a lot of information. 890 slides. No questions? Well, let's fill in the evaluation form, see what you think, and if I can help you with anything, let me know. We do a lot of geotechnical all around. So all over Texas. So if you need any help, let us help you with the projects. Let's see. Got any questions here? Thank you, thank you, thank you, thank you. A lot of thank yous. Well, please fill in the poll. Let us know what you think. And if you have specific recommendations, please shoot me an email with your comments. I'll try to implement them. Other than that, let's see. Thank you. Always good. Thank you. I think the greatest benefit is really what you don't know. Okay. Yeah. Why don't residential builders stabilize clay soils to prevent slap movement? Um, and a lot of the home builders do chemical injection if their PVR is greater than 4.5. Some builders do it when the PVR is 3.5. And if you do a custom homes, or we do a lot of custom homes, a lot of these custom homes going on drill shafts with structural slab, depending how much they're spending on the house. Most of the track homes, they're going to post tension slab. And if the PVR usually less than 4.5, they don't do anything. They just compact the soil, put the slab on it, and 99.9% of them perform fine. Thank you, thank you, thank you. Okay, why builders putting walls up on concrete that has been placed for 3 days? Theoretically, PTI says do not put walls in there or stress them unless your concrete has about 2100 psi. So I don't recommend people going out there and start putting walls in when concrete's still fresh.